There are different ways to express the concentration of solutions. And what is a concentration? It's a measure of how much solute is dissolved in a given amount of solution. The first is weight by volume percent. Weight by volume percent is the number of grams of solute dissolved in 100 ml of solution. How many grams of solute can be dissolved in 100 ml of solution? So let's look at this problem. 0.30 grams of phenol are dissolved in 25 ml solution. What is weight by volume percent or weight by volume percent concentration of phenol? So we know that weight by volume percent, that's equal to grams of solute, which is 0.30 grams, divided by milliliters of solution. And how many milliliters of solution are there? 25 ml. And to change it to the percentage, you multiply by 100. So your answer will be 1.4% weight by volume phenol. That means if you dissolve 0.30 grams of phenol, using that you're making 25 ml of solution, you can call that solution as 1.4% weight by volume phenol. Similarly, let's look at the second one. The second one is volume by volume, means we have solute, liquid, and your solvent is liquid too. Volume by volume percent is the number of milliliters of solute dissolved in 100 ml of solution. So let's look at this problem. 750 milliliter bottle of wine contains 101 milliliter of ethanol. So again, a 750 ml bottle of wine contains 101 ml of ethanol. Find volume by volume percent concentration of ethanol. So volume by volume percent is equal to volume of solute. What is your solute? Ethanol is your solute, which is 101 ml, divided by volume of, let me move this little bit here so that I can write it down. So volume by volume percent is 101 ml of ethanol divided by volume of solution. And what is volume of solution? 750 ml. And to change it to the percentage, you multiply it by 100. So when you solve it, you get 14% volume by volume ethanol. So here when you take 101 ml of ethanol and you make the solution of that, and the rest is the water, then you can call that solution as 14% volume by volume ethanol. The next, which is very important, is molarity. And what is molarity? Molarity is the number of moles of solute in 200 in 1 liter of the solution. So here again, what is molarity? Molarity is moles of solute divided by volume of solution, and that volume of solution has to be in liters. So molarity is moles of solute divided, and these are the moles of solute divided by volume of the solution, but it has to be in liters. So let's say if you have a question, you have to calculate the molarity of a solution made from 20 grams of NaOH in 250 ml of solution. 250 ml of solution. So what is the molarity? You took 20 grams of NaOH, you dissolve it in enough water to make 250 ml of the solution. What is the molarity? Now first thing is the moles of the solute. Solute is sodium hydroxide, but you are given in grams. So the first thing you have to do is to change these grams of sodium hydroxide to moles of sodium hydroxide, and 1 mole of sodium hydroxide equals to how many grams? 40 grams. Add all the atomic masses. So first thing first, you have to change these 20 grams of sodium hydroxide to moles, which will come out 0.500. Next thing, your volume is 250 ml. That's given to you in milliliters. You have to change it to liters. And 250 ml in liters, you change it by dividing it by 1000 will be 0.25. And how many moles are there? 0.5. So 0.5 divided by 0.25, it will be 2.0 molar. So 20 grams of sodium hydroxide dissolved in 250 ml of water or 250 ml of solution, you call that as 2 molar solution. The dilution. Now what is the dilution? Is the addition of the solvent to decrease the concentration of the solute. Let's say you're making a cooler solution and you taste it and say, oh, it's very concentrated. So what do? You add more water. Means you add solvent to decrease the concentration of a solute. Now, but what happens when you are decreasing the concentration of the solute? Uh, you are not changing the moles. So what it means, so let's say you have a Kool-Aid solution, you took some Kool-Aid, that powder, you add it to the water, and you make this, and you saw the solution is very concentrated. In this one, you added some more water to make the diluted solution. But did you change the amount of the Kool-Aid? No. Did you change the moles of Kool-Aid? No. So the moles of the Kool-Aid before dilution and after dilution, this is before dilution and after dilution stays the same. And so here this, and what is moles? Moles is molarity times volume. So M1V1 denotes the moles of the solute or the moles of Kool-Aid before dilution, and M2V2 denotes the moles of the solute after the dilution, and the mole stays the same. So let's say if you have a question, what is the concentration of a solution formed by diluting 5 ml of 3.2 molar glucose, this is glucose, to 40 ml. So again the question is, what is the concentration of the final solution? What do you have? You had 5 ml of 3.2 molar glucose solution, and you changed the volume to 40 ml, means you added more water. So M1 is the molarity before dilution. What will be M1? M1 will be 3.2. So your M1 is 3.2. What is V1? Initially you started with 5 ml equals to, what is the new concentration? That we don't know. But do we know the new volume, the final volume? Yes, 40. So we have 3.2 times 5. Let me write down that again here. 3.2 times 5 equals to molarity times 40. And to solve M2, you have to divide both sides with 40. And when you solve this, you will get M2 as 0.40 molar. So that's the new molarity. So when you're diluting it, you can see the concentration is getting less.
Made with Doodlecast Pro.